How's your cough?
Why?
Because we're recording, and I wanted to talk about the possibility of what your disease is. No cough for the camera?
You should have been recording like 10 seconds ago.
Well, it wasn't exactly perfectly timed. I was having difficulty with loading the recording. Okay, well, anyway, people, let me tell you exactly what's been going on. My girlfriend's been having a bad cough along with some other things, swollen lymph nodes, headaches, a bit of fever. So I looked up on WebMD to see what she might have, and the first topic that came up was anthrax. I wonder if there were some mathematical way to actually check to see whether or not this anthrax is actually real, or whether she actually has it. Oh, wait, there is a way I can check. It's called Bayes' theorem. This is pulled straight out of the book Probability and Statistics for Scientists and Engineers by J.L. DeVore. This is how to use Bayes' theorem to tell if you actually have a infectious disease. The way that you actually tell is not based on the accuracy of the test, but is actually based on the likelihood of the disease being prevalent in the population. So take, for example, incidence of a rare disease. Only 1 in 1,000 adults is afflicted with a rare disease for which a diagnostic test has been developed. The test is such that when an individual actually has a disease, a positive result will occur 99% of the time, whereas an individual without the disease will show a positive result only 2% of the time. If a randomly selected individual is tested and the result is positive, what is the probability that the individual actually has the disease? Well, if we take a look at the chart here, you have to construct a probability tree first. So 1 in 1,000 means that there's a 0.001% probability of them having the disease and a 0.999 probability of them not. Multiply that by 0.99, and you get 0.00099 probability that they have the disease given that they tested positive. Now also, you have to calculate the probability that they test positive but do not have the disease, which in this case is 0.01998. Add those two probabilities together to get the total likelihood of them testing positive, which is 0.02097. Then you divide the probability of them having the disease by the probability of them testing positive in terms of all probability, 0.00099, divide by 0.02097, and you get 0.047 or 4.7% that they actually likely have the disease. So just because WebMD tells you something given a set of symptoms, or just because you get a test positive, does not automatically mean that the probability that you actually have the disease is very high. The next time you get a bunch of symptoms and you decide to check with WebMD, or you get a positive test on a disease thing, check with the doctor what the actual prevalence of the disease is in the population to determine what your actual likelihood of the disease is having. There's a little bit more on this. The probability of having the disease has increased by a multiplicative factor of 4.7. But to get a further increase of the posterior probability, a diagnostic test with a much smaller error rate is needed. And while we're on the subject, let's mention one other thing. Misha, you were a nursing student. What was that talk about the increase of a rate by 50% when dealing with diseases?
It's absolutely hilarious. People will completely flip their shit. Like, supposing the general population has an 8% chance of getting a certain kind of cancer. Now, somebody has certain risk factors, and the doctor says your chances of getting this certain type of cancer will be increased by 50% due to the risk factors. That does not mean that you suddenly have a 50% chance of getting that certain type of cancer. That means if the general population has an 8% chance, you take 50% of 8, which is 4, add the 4 to the 8, and your chances of getting that certain type of cancer are still only 12%.
So that's so there you've had it, people. This is a practical way to use math. The next one with regard to diseases. So the next time you actually think that you have a disease given WebMD or a particular test, do not automatically jump to the conclusion you have the disease. Check for the prevalence of the disease in the population first. Using this particular test or probability tree, calculate out your likelihood as per the use of Bayes' theorem, which is also described up here if you want to pause the video in full. And you might actually have a better shot of being able to tell what the likelihood is that you're actually infected with that particular disease or some other disease. This has been Math and You this week. Hopefully this is actually something practical you'll learn from. Remember, if you have any questions that you would like answered mathematically or would like tutoring services or statistical consulting, please contact me at guthrie.prentice33@gmail.com. This has been Math and You. Stay tuned for future episodes.